Okay. Okay, well, that's in the other section. I'll make it up. Okay. So this portion of the workshop will be recorded, and I will point out for everybody leaving, as you're leaving, that in the Velma folder, there is now in notebooks complete version, so you can walk through it with that later as well. All right. Stu. All right, can everybody hear me okay? Everybody still with me? Awesome. All right. So I am sharing my full screen right now because I want to make sure that everybody is going where they should be. I'm going to walk around just to make sure we all start out at the same location. So, okay. Did I type something wrong? Yeah. Honda deactivate. Start out with a typo. Always a good way. All right. So if you're in your folder where you have this, I just want to make sure that everybody has pulled and has the most up-to-date version. That includes a complete version of the notebook along with a paired pie file. If you want to learn more about paired pie files, I suggest checking out the internal guidelines wiki and some of our suggested tools. But these are available here. There is also the incomplete version, which I will be typing, and feel free to follow along with that. So going back to our terminal, can I get a green sticky that everybody has the correct version up to date, ready to go? All right. Yeah. It's entirely self-contained. Yep. Okay, so as long as you update your repo now. All right, so we will Conda activate our data workshop 2024, and we will launch Jupyter Lab. And at this point, I will change my screen sharing to be just my browser so I can make this larger and hopefully everyone can see a little more clearly. All right, so we're going to go into Velma, notebooks. I'm going to make this bigger so I can see which one's complete. Okay, so there's the complete version and there's the incomplete version. I will do the incomplete version. Feel free to use the complete version as a reference. We're also going to open up the README, which I will recommend. Also doing that trick that John mentioned in the last one is we can go open with and do markdown preview so that you can kind of see it as it's getting updated. So I just want to check in. Everybody have their notebook and at least the markdown version of the README open. Okay. So in our last session, we went through, we saw John was dealing with Shaggy's data. It was a mess. We couldn't really do anything else with that afterwards. We had Matt go through as Fred and solve our mystery of, okay, stuff got added, stuff got removed, and we don't really know what's going on with this. Let's just get an MD5 of all of the images and attach that into our CSV so we can figure out what's up with these duplicates, and we'll use the original data set and start where Shaggy should have started last year. So I will also note the disclaimer that this is a toy data set. In reality, you definitely need more data to do this. So there will be a couple of assumptions near the end where, you know, this is just to demonstrate real world challenges in data collection and curation in a digestible format that we should be able to finish inside of an hour and 20 minutes at this point. So we can do our imports and we're going to explore our original data set. While that's going, I am going to copy the link for I'm going to open up the original data set because I want to add that to our README. So if you copy that link, this takes a minute to go. If you notice in the README at the top, we just have images of butterflies with sex metadata. Might want to add a little more description of that. So we can say images of butterflies with sex metadata sourced from, and we can just call it Imageomics data set. Notice the brackets, parentheses, add the link. Now there's a URL reference back to our original source. So let's look at our data set. We have 110 entries. That's good. But we have this type status column has only two non-null values. So we can check out what is that. I think it has something to do with some kind of, oops, gotta close that bracket. It's something biologically related, but I am not a biologist, so I would ask a biologist. What are we looking at here? But we have two entries. We can print out, let's see. We have, how many unique subspecies do we have? df.subspecies.unique, and unique, should have erased that. Unique subspecies and type status is in, and I'm going to end it there, do a new line and just print out df.loc, find our instances where type status is non-null. You might ask, why am I bothering typing all this out, right? This is like a lot of work to type all this stuff out and everything, because next semester, when somebody comes back and wants to see what it is that we did and how we made this data set and why we did what we did, they can look at this notebook and the explanation is going to be right there. We have 6 unique subspecies and type status is in one of them. I think we can drop that, right? All right, so if you really want to be good documentation, we change the cell to markdown. We'll drop, oops, sorry about that. The type status, that's why it's still reverbing. Okay, we'll drop the type status column. And before we drop it, we'll come back over to our handy dandy README. And let's make a note down here. We're going to scroll down to data set creation. So we want to make sure that we're also writing the data set card instead of going back after you've done it. And it's like, it's a month later. Do I remember what I did last month? I don't know. How about we just do it as we go, right? So we can say the following steps were performed in the generate Imageomics splits notebook. That way they know where to look if they have questions about more details using the Imageomics.csv created in Fred/mystery thickens.ipynb. And in that one simple sentence, we have given the entire provenance of what it is that we were working for. We have told someone where to go if you're trying to understand what is going on with this data set. You go back and you look at this notebook where this CSV was generated, and up at the top, we told them where that started with. So our steps. Come down here. Our first step was Imageomics image metadata was augmented with MD5 column, right? So that's what we're looking at originally. And then we are removed type status column. That was nearly all null. Okay, so we've given a little bit of explanation, but not all the details. And if you go back and look at your nice version, now we have some bullet points. So we're going to come back, we're going to drop that column, right? So we'll do, click it, calls equal, nice little list comprehension, make things easier. df.columns, if call not equal to type status. That way we make sure we get all of the columns involved as long as it's not equal to type status, right? Okay, we do df.head, take a look at that now, and we don't have that messy column. Now, there is one thing here that's kind of bugging me. We have this column that's got spaces in it, and those are annoying to work with, right? I mean, look, just up here, we have dot subspecies. You can't do that if you have spaces. So I'm gonna copy that, and what I'm gonna do is we're gonna rename it. So, but before I rename it, I'm gonna, again, make a note of what I'm doing, right? So rename column with space. Easier to work with column names that have underscore instead of spaces, right? So we will do df.rename columns, and then let's paste that in there. I'm going to paste it again and just go back and put in those underscores. I'm not changing anything about the information that's provided, but I am making sure that this is more functional. And we will do that in place equal true so that I don't have to do another reassign. Now, all right, everybody still with me? I get some green stickies. Oh, sure. Yeah. Collapse this, it'll be easier. Is that better? Okay. Okay, so we will go back to our README as this is another thing that we have done now. We renamed, and hopefully you still have this on your clipboard. Oh, yeah, renamed NHM specimen number as, again, go back, add the underscores for easier processing. Okay. Now, let's come back. Let's see. So Fred said that Shaggy's data had some duplication, right? So let's check that duplication. So we'll do df.nUnique, and this will give us information about all of the unique values in each column. Let's see, our IDs are unique, so let's do a markdown. Let's note down what we observed. All right, so observations. Can someone tell me something that you've observed by looking at the number of unique values here? Can you tell me something that you've observed when looking at the unique values? So say about column ID. What's meaningful about that column? There are more sexes. That is yes. Okay, why do we have 4 sexes? That's a good question. I am not a biologist, but I don't think butterflies have 4 sexes. Other observations. Yes, we have 76 unique MD5s, but 110 unique IDs. And on top of that, we do have 110 entries. So what can we say? At least IDs are unique, right? Any other observations? We have 4 views also. We don't know if those are actually all distinct. Any other observations? Matt? Yes, all right, so we expect that specimen number times our number of views, that way, number of views, would equal our unique MD5s. Let's do it. It's not gonna do it. All right, num specimen number. All right. But it does seem that we have half as many unique specimen numbers as unique MD5s. So that's a good indicator. We probably should have 2 views, right? All right. Okay, so let's take a look at those different views and those different sexes and see if they're actually something that we work with or if we should do something about that. All right, investigate bf.sex.unique. So the nice trick with doing it this way is that as opposed to on a value count, we can see there's an extra space added in here, right? So we'll just make a note. We got this on dorsal and male. Both have entries with extra space, and we have inconsistent capitalization. So we definitely should only have 2 unique views and 2 unique sexes. So let's fix that, right? Let's see, well, standardize column contents. Okay, so we want to do df view equal to df dot view dot string. So we need to take it as a string, and then we'll set that to lowercase. Notice I'm doing a difference here on the actually typing it out in the brackets with parentheses and then setting it equal because I'm setting the column name equal to this. If you don't do it that way, you will get an error. And then we'll set, so we know, in this case, we know the 2 instances where we have some silliness with missing white space. So we'll just adjust that when it equals dorsal with a space and view and set that equal, oops, those brackets. Clearly I use VS Code too much. I'm way too used to it closing things for me. We'll set that equal to dorsal. And we'll do something similar for sex. And we'll find the one that was male with a space. And excellent. Not gonna make the same mistake twice. There we go. And then we can do a quick check on the distribution. We can do print df.view.value counts. And print. It's also a good check that it did exactly what we wanted it to do, and we don't have anything else weird here, right? There we go. All right. Oops. Okay. So it looks like we have an even split between our dorsal and our ventral. Male-female distribution is not quite even, but that's okay. We'll work with that later, right? So we can make a note. Even split on views. Sex ratio. Not balanced. Okay. Now, let's figure out what's going on with those duplicates. But before we do that, can I get some green sticky notes to show me if everybody is still with me, or pink if you got lost somewhere? I'm gonna get a sip of water. All right, I see enough green sticky notes. I'm gonna keep going. So let's look at duplicates. We've got, we'll set a duplicates column. Oops. And we're going to use handy.duplicated method from pandas. We'll do that on the MD5. And what we're going to do is tell it not to keep anything. So that means that every single entry that is duplicated is going to show up, even the first time that it shows up, so that we can get a little glimpse at what this looks like. So let's see how bad this is. Woo! All right. So what we can tell from this is that we have 42 unique images. And at least 34 images are duplicated. Right? So let's take a quick peek at what things look like among those duplicated images. So it's not as simple as we're just going to remove things, because we need to make sure that that metadata is still going to match, right? So let's make a duplicates data frame itself. Ooh, I'm looking at the wrong thing. df.loc. We want df duplicates. So this is just a Boolean value. So we're saying we want that, but we want all the instances where it's a duplicate. And then we'll look at the unique values there to start. Okay, so the good news is we do seem to have just 2 copies of every image. Our specimen number is still half the number of MD5s, and the number of MD5s is half the number of IDs. So we definitely have, no, we have unique IDs. And 34 images are duplicated. And that is across both of our views, sexes, and species. Also 3 of 6 of our subspecies. So we have some no pattern to our duplication, but we have duplication. So now what we want to do here, let's check consistency. So this is a really important point. When you have duplicate images, that doesn't necessarily mean that all of the metadata across of those images is the same. So we want to make sure that the metadata for all of these images is consistent. Because if the metadata isn't consistent, then unless that's something that we can actually go back in and check and rectify, we can't decide which record is the correct record to keep, which means we would have to either remove both of them or go find some other source to tell us which line of metadata is the correct line to keep. So let's make another column subset for the columns that we're going to look at and see if these work. I'm hoping I still have NHM specimen. Oh, I do. That was still on my clipboard. That's nice. So we want to check the specimen number, right? Because if it's the same image, but the ID of the specimen is different, then there is no guarantee which specimen that actually is. And that ties us to all the rest of our metadata, but we still want to make sure the other metadata is complete, is consistent. So we'll check the species, the subspecies, the view, the sex, and of course, the MD5. Now we'll do duplicates, dot duplicated, look at those stats columns. And in this time, we will actually keep the first instance that something shows up. So if you had, ID 4 and it's the specimen number 1, and the next one is specimen number 1, and they both have all of the rest of the same information, that first one won't be marked as a duplicate, but the second one will. And we're going to look at our value counts and see what it tells us about what we're looking at. Because right now we're only looking at the set of duplicates for the whole data set. All right. And that is what you would hope to see when you look for duplicates. I can tell you from experience that is not always the case. But we have 34 images that are indeed unique here and 34 that are duplicates, and they are all across these columns. So we're in good shape because that matches the number of unique MD5s that we were expecting to find. So we can say, all metadata seems to match. So we'll keep the first instance of each of these duplicates. Now, what haven't I done in a while? That is true. Good point. Something else. Exactly. I have not documented what we did since we renamed the specimen number. Oh man. All right. Well, what did we do again? Let's go back and look. All right. So we changed the specimen number name up here. And then let's see. We checked for the duplication, found some weird stuff, and we fixed the weird. Oh, there we go. Standardized column contents. Great. The bullet point writes itself. Standardized column contents. All right. Did we do anything else before we got down here? Let's see. We looked at the duplicates. We checked consistency across the metadata. All right. Check consistency across metadata. And that's our next step now. Removed duplicates based on matching. Yeah, remove duplicates based on matching MD5s. Check consistency. Remove duplicates based on matching MD5s and other identifying information. All right. Okay, past tense. And I will save my README because it's always good to save as we go, right? Okay, so let's do that cleaning up now. So we will reuse that duplicates column in our original data frame, right? So we're back on DF, we're looking at duplicates, and we're going to rename this column duplicated based on those stats columns that we just defined above. And this time we will keep the first instance of each of those because we know that they will be fine. And we will collect everything and we won't lose any information and we won't mislabel things. So now we've got duplicates. Oops, we'll check our value counts again. Make sure that our numbers still match what we're expecting. Good. Now that matches what we expected. There were 34 images that were duplicated and there are 76 unique images. So we are off to a good start there. And we will do, let's now make a new data set. So we're going to call data frame, sorry. So we'll call this cleaned DF. Is going to be our DF. And now we're going to find the instances where we are not looking at duplicates. Helpful when you name the column for the thing that is in there. No, you don't want, right? So we can get some information coming off of there. Oops, .info. Let's see. All right. We now have 76 entries as we expected. Everything is non-null, so that's good. We've got something there for everything. Let's also take a look at the number of unique entries for everything. And this should match pretty nicely. It does. We've got our 76 unique IDs. We still have 38 unique specimen numbers and 76 unique MD5s. There is only one value, excuse me. There is only one unique value in our duplicates column, which at this point we can remove. So let's do cleaned. I'm going to say run this once, only once. Cleaned DF is now going to be reset as cleaned DF. And then we want to get our columns. Columns. And we want all of our columns except for the last one, because the last one is that duplicates column. And if you want to be extra careful, you can print out afterwards. And we'll just look at the head. That'll show us that there's all the columns we expect to be there. And it gives us a good reminder of the information that's there. Because one thing that we haven't documented yet is what columns are in our data frame, or in our data set. And at this point, I think we're pretty good with the columns that we have. So let's go back to our data set card and let's record down what columns we have. All right, so if you scroll up to our data fields, more information, we're gonna add that now, so we don't need to leave that. So we don't have a file name column anymore, but what we do have is an ID. So the ID, what's important about the ID column? What's special about it? When we look at our number of unique values, what's special about ID? Right, it's unique. So ID is our unique identifier for this data set. And we could put in a little note about what it looks like. Let's see, what do those values look like? You've got KDS and 6 digits afterward, right? So KDS 3, 4, 5, 6. There we go. All right, our next column is, oops, going to tabs instead of there. All right, our next column is the specimen number. I'm going to copy that because it's long. We don't need to waste time typing. Not for that. So specimen number. This is presumably the identifier that is associated with the butterfly in the image. And it's assigned by NHM. I'm going to assume the Natural History Museum. Generally speaking, you would go back, look at the data set, look at the source, get a little more information, find out a little more information about that. In this case, we will stick with, that's what it is. So next up, you've got view, right? So the view is the view of the butterfly in the image. And we know that that is either male or, oops, not male. That's what happens when you start looking at the next line down, right? We've got dorsal or ventral, right? So it's helpful if you tell people what options there are. So our next column is going to be species. So species, also pretty self-explanatory, but doesn't hurt to type it out. The species of the butterfly in the image. Now, what species options are there? We haven't looked at that. So let's print that out. Cleaned df dot species dot unique. Our list. All right, Melpomene and Erato. And just copy that in. There we go. Species in the image, Melpomene, Erato. Next up is subspecies. We've got the subspecies of the butterfly in the image. And again, we'll go back. This time, I'm going to copy this, keep us moving, right? And just put in subspecies dot unique. All right, here's our list of subspecies. So we'll pull that over here, paste that nice list in there. And our next column is sex, which we already have here. We can adjust the formatting. We did confirm it's male or female. That's good. And after that is just the MD5. MD5, which is the MD5 of the image. And we'll note that this is after reading with pill. As we learned exploring our mystery in the last session, it does matter that you have opened this with pill, so it's good to let people know so they don't get confused if they try to look at it with something else and compare to the original. Now we'll leave a space. We will make a split column, but we're not there anymore. I think we can erase our to-do, save our README, and let's go back to our notebook. So where are we at? We have made a cleaned data frame out of all of this. So you know what? To make things easier for the next person, if somebody else wants to work with this data set, they might not be doing the same exact project that we're doing. So before we start making any other changes, why don't we save this cleaned data set? Cleaned version. All right, so we will save clean version. Yeah. All right, so save a cleaned up master file of Kaidomos data set. All right, so we'll do cleaned df.tocsv, and let's save that, oops, not with commas, into our data folder, and we'll call that Kaidomos cleaned.csv. And then you want to make sure that you set that index to false so you don't wind up with that weird unnamed column the next time somebody tries to read this in. No need to add extra columns. All right. So now we have a saved clean version. We should make a note of that in our README, right? So we'll come back down to data set creation and we'll do save. We'll note that we have saved a cleaned copy of the metadata. And we can say we saved that in the data folder and called it Kaidomos cleaned.csv, with the idea being that somebody is going to be looking at your repository and they will be able to see where these things are. So you're giving them the frame of reference for where to find the information that they're looking for and where to find the files that they're looking for. Now, let's go back to our data set and we are going to take a look at our distributions, right? So we want to check the distribution. Check distribution of data, right? Because we want to be predicting something, but we have to make sure what our representation is and that everything that we're looking at is represented, right? So here we're going to use Seaborn. It's a handy hist plot. We can just pull this right up, cleaned data frame, and before I type any further, I should check that everybody has managed to save without having any errors thrown that have thrown you off. Everybody good? All right. So we want to look at our subspecies distribution, and we can look at the hue on the species. So we'll color by species so we can see, do we have a nice distribution? What are we actually looking at here? Because we know we've got 6 subspecies and only 2 species. And there we go. Like I said, I'm not a biologist, so I printed out that list of subspecies. It did not mean anything to me. But looking at this here, okay, Melpomene, I probably could have guessed was a Melpomene subspecies, but that's still weird to me. So we have 2 subspecies here of Melpomene and 4 of Erato. And some of them are balanced, but they're not all entirely balanced. So that's something that we're going to have to pay attention to. Let's check how this plays out when we're looking. Now that we know which subspecies belong to which species, we can take a look at where we are on some of the other descriptive columns that we care about. So let's look at subspecies again. And this time we're going to color by view. So here we can confirm what we suspected, that we have 2 views per image. There you go, each one. We've got a nice balance between dorsal and ventral. And you can make these look prettier if you want, but that takes more time than I want to dedicate right now. So we will note dorsal and ventral are balanced as expected. And let's check the thing that we're really concerned about, right? We want to try to predict sex of butterflies from images. So we better check that there's a balance on that, on the sex. Otherwise we'll have to, take care of that. So subspecies hue equal sex. Oh, well, there's a problem. We have 2 subspecies here that don't have any female specimens. Pretty hard to predict something there if you're only giving it one side, right? That's not the way we were planning this project. So what we're going to have to do is, at this point, we'll remove these subspecies. So here, I'm going to harken back to that disclaimer. Assume we had plenty of data and this is fine. We can drop it. We're not creating an absurdly small model. So, okay. So we'll note we have 2 subspecies, both Erato, that don't have any female specimen images. So we're removing them. And we can make a note of which ones. I'm going to do this with that so we can copy it later. Amalfreda and Lativita. All right. Now, before or after, remove skewed subspecies. Let's call these skewed SSP, and we'll make a little list. I'm going to copy these because I typed them out before, so I can copy them now. Right, so these are the subspecies that we're going to remove. And now we're going to rename our data set again. We're going to call it something new because we're no longer working on just the cleaned one. We're reducing this thing. So let's make a clear distinction that we're doing something different here, right? So clean DF, and we're going to look for instances not where we have our cleaned DF and we want subspecies that are not in the skewed subspecies list that we made. And we're going to copy that, make a copy when we do that, so we don't wind up doing extra slices on slices on slices. Panda does not like when you do that. And then we will give that, let's look at our reduced df.n unique. All right. We have cut our data set down a bit. We now just have 4 unique subspecies, but we still have everything else represented. Now, before going any further, what should I do? I'm sorry, I can't hear you. Can you talk a little louder? Exactly. In the README, we have to document that we have made these changes. All right. So what did we do? We removed 2 subspecies of Erato that did not have images of any female specimens. And those were these 2. Now, in our README, we also made a note on our columns of subspecies. We should remove these 2 because they are no longer in our data set. I don't know why that isn't coming up. There we go. Okay. So we're moving on along here, right? Okay. So now we need to make some splits, don't we? If we're going to train, we got to have a training set and a validation set, right? So let's change that to markdown. Make splits. Now, remember, we do have balanced views. We know that. But we also know that so we have 2 splits and they're balanced. We have, 2 views and they're balanced. We've got dorsal and ventral. But we know that all of our specimens have both a dorsal image and a ventral image. Now, we don't want those getting crossed, right? We don't want our model training on one specimen and then seeing it in the test set. That just gets messy, right? So we'll make a note. We need to separate them out, right? Each specimen has a dorsal and a ventral image. Separate dorsal to generate splits. So in this case, it doesn't matter which I choose. Could choose ventral, but I'm going to do dorsal because who doesn't like a little alliteration with dorsal DF? So we will get our dorsal DF and we're going to pull from reduced DF. We will need that later. And we are going to look for the instances where we have our reduced DF view is equals dorsal. Right? So we'll just get all of these and let's copy that so pandas doesn't get upset. And quick check uniqueness. All right, there we go. We split our data set in half and we're represented across everything. Now, remember we had a bit of imbalance, it looked like, along our sex representation. So let's just pull that up again. Look at distribution. All right, so we can do sns.histplot and we'll look at dorsal DF and check subspecies and color by sex. All right, I'm going to take a moment here to just go back a sec on a note. When we removed those 2 species, those 2 subspecies that didn't have the female images, they were also both Erato, and we had more specimens from Erato, so now we have balanced out between the Melpomene species and the Erato species, but we are still, well, balanced out, sort of, in that we have two subspecies of both. We do have a different number of images for each of these, and it is distinct numbers of sex. It's only balanced on one of the subspecies. So what that means is that we want to stratify when we make these splits so that we make sure that our training and our test data are both representative of our actual overall data set. So we'll just make a note. We'll stratify to make sure our training and test represent the distribution of our overall data. Stratify on, in this case, so part of the reason I mentioned the species is that we are going to do it on species and sex. Really, you should do it on subspecies, but we do not have enough data in this silly toy data set to do so. So we will so I will note that down as well. Species and sex. In real world should be subspecies and sex. But toy is too small. So that would be a good indicator that you need more data. Right? All right, so we will use, we're just going to use train test split from sklearn. So we've got train df, test df is going to equal train test split. And we're doing this again, just on the dorsal data set. The test size, 20%. Stratify on dorsal df, species, sex, and most importantly, or definitely importantly, let's set a random state so that somebody else can regenerate this later, or we can regenerate this later if we have a problem, and we're still going to get the same results, right? Comment there. Set random state for reproducibility. And if you're wondering, 614 is the area code for OSU, and I learned at OSU, and I am so used to putting random state 614, it is almost automatic at this point. Get a little humor in there. Tough crowd. All right. So now we have our splits. Well, we have our dorsal splits. So what should we do next? Actual splits, exactly. Now, great, we made a dorsal split, but we're not training on just dorsal images, we're training on the whole thing. So we're gonna add ventral images to our splits. All right, so how we're gonna do this is we're gonna look at, remember that specimen number goes across. Each specimen has a dorsal and a ventral image. So we will get a list of specimen IDs in the test set, in test set, and add all with that ID. So how that will work, get our test IDs is going to be our list. And we're going to look at the test DF NHM. I know I have to type it this time. Specimen number dot unique. So here we're getting the list of all of the unique specimen numbers, which they should all be unique in our test data frame anyway, so I don't actually really need that unique force of habit to get the list of the test IDs. And then what we're going to do is assign images. So we're going to come back to our reduced data frame. And we're going to make that split column. So let's first just assign everything to train. And then we'll slice our slice our data frame and look for our specimen numbers. Okay, typing and talking can be hard when you're doing two different things. All right, I'm going to copy this out from here. So we're going to look for our specimen numbers that are in that test IDs list we made. And then we are going to assign the values, the split values for those IDs to test. And then we can do a quick little check. Check. Reduced df.split.value. Ooh, caps lock. Value counts. All right, there we go. We have our 80-20 split. Now what? Other than, yay, we have a data set we can use. But before we leave this notebook and before we go and get all excited about how we're going to train this model, what should we do? Save the file, yes. Oh, yes, we definitely want to save that file, right? But if we say I closed this notebook right now and then I went, oh, no, what now? Could I remake it? Yep. Every single step we've done is reproduced. We even have something we could reload in our cleaned data frame and go from there and reduce it. We wouldn't even have to do the first half of the notebook. But we're still going to save it because that's much better. All right, so save our completed data set. And we're going to do reduced df.2csv. And we're going to put that into that data folder. We'll call it butterfly images. Nope, that's not how it was in the thing. Butterfly images metadata. If you remember from the beginning, that was the name that we have on our dataset card for our data set. So we'll give it that. And then again, we want to set that index to false so that nobody has to deal with an unnamed column because that's really annoying. All right, yay, we have a data set. Now, how's our documentation? Did a little bit since we last wrote in there, right? All right, so let's come back to our README. What's the last step we did? The last step was when we reduced our data set. All right, so let's go back and figure out what did we do since we reduced this down. Oh, here we go, remove skewed subspecies. Okay, that's not so far back. So we made splits. All right, let's record that down. So we generated splits, but we did this in a very particular manner, right? So we separated dorsal images into their own data frame, data frame to run the train test split package from sklearn, stratified on sex and species. And let's see, then what did we do? So we split it out and we said, right, we looked at this and then we pulled the ventral images back in, right? So then images of both views were assigned to train or test splits based on NHM specimen number to avoid data leakage. All right. That seems pretty good. We can say saved metadata file, and data slash butterfly images underscore metadata dot CSV. Okay, so I think we can remove now everything down here is based on the Shaggy data set. So we can remove this block of text. Now we're going to come back up. We've got the data split, right? So let's describe the data splits. We can remove everything about Shaggy's data because now we're talking about what we did, right? So splits are marked in the metadata file as train or test. The test set is 20%. Oops, 20% of the data balanced for species and sex, as view is already balanced in the data set. Both images of a given specimen are in one or the other split. Right, so we let them know it's marked as train and test. It's 20% for test. We balanced it out based on our categories that aren't balanced, and the ones that are, we left alone. We made sure that specimens are unique across the splits. And if they want more information, they can go down and look at data set creation or further look at the notebook where we did this. Okay, so coming back up, data fields. Okay, so we should note split, right? Train test split, either train or test. We have more information below in the data split section, so that's fine. And we can fix the data set structure. So when we pulled this in, honestly, we should go look at, oh wait, I still have this open. Let's go look back at that data set. So the image, the ID is, I believe, the image name. Now, because we're using the original data set where the image name is actually the ID of the image. So we'll specify that this is ID 1, ID 2. So that way we're telling somebody it's based on the IDs down to, well, how many images? Oops, 1, 2, 3, 4. We know how many images are in this, so we don't need to leave ellipses and leave somebody guessing, right? We've got 50 images. Let them know that there are 50 images in this data set. And metadata, we named it for our data set. So the butterfly images metadata.csv. If you're going to be sticking this into a Hugging Face data frame, it is helpful to have the metadata.csv because it can do some reading off of that. That is how this dataset viewer is able to unify the information. Though in that case, it would also need that extra file name column that gives you a path to the image. So we're not going to get into too much detail on that. That's further reading, other topics you can explore. Right. So up here, we just have some notes on like helping you to do this, right? You can add more tags. With your repo, you want to think about licensing. And when you're done with this, you can remove the comments once you've done this. There's also some notes on just how to deal with Hugging Face has different markdown from GitHub on some things. So there are some notes here about how to do stuff you might be interested in adding into your README card for more information, like including a figure and having a caption attached to it so that somebody knows what they're looking at. And if you need any kind of LaTeX for math symbols. Additionally, so we have the license, the language, pretty name. We can call it, it's still just going to be butterfly images, so that's fine. Task categories, you might say, okay, well, this is going to be, image classification. I think it should have a dash. When you go into the UI on Hugging Face and you go to edit a data set card, it will show you a lot of these things and you can start typing. It'll give you a drop down and you can select them, so that we'll format that properly. So if you want to do that way, that's also a good way of doing that. So we can add some more tags to this because these are keywords. So this helps people find the data set, right? So what do we have in here? We've got butterfly images, right? So butterfly, always a good keyword. We know we have Erato. We've got Melpomene. Could say dorsal, ventral. Yeah, go down the list. Things that people might be looking for when they're looking for a data set. Different types of things to help narrow it down. The more tags you can include, the better, because it helps people find your data set, right? Another good thing is size category. People are usually looking for, particular size of data set might be important. So we want to note this is the smallest category, is that we have less than 1,000 images. Going further, you can add in, homepage. If you've got a repository for this repository, you're related, you did all this work on GitHub, you uploaded it back to GitHub, put a link so people can find it. All those kinds of extra information. You can give more information about your data set, talk about, put your results and different things in there. I don't think that we necessarily resolved how many types, but we know that it's TIFF, approximately the size. You've still got a to-do, so find it later, right? And going back down, this is a lot of giving people more information to understand your data set, where it came from, and why they may or may not want to use it. So why did you make the data set in the first place? Where did it come from? So for this one, and it is fine to give the information, basically, we downloaded this from, and I'm going to come back up to the top and copy that link. Now, it's good to give some information down here, but you can also just put, and this is maybe a good to-do, right? To do, get later information from original source. You can say, this data was collected by this source. Obviously, make it clear that this is something you didn't do this process, but you pulled it from somebody else who did. And if there were any changes that you did to the data, then you would still note that here and say, following, source annotation was maintained, and views and sexes were standardized. And you could say, case, comma, spaces or something. Just give some indication of, look, I've made these changes, but I didn't change any of the actual meaning of the information underneath here. I let someone know what the difference is. You can give some other information, talk about biases or other limitations. Well, let's see, this data set is way too small, but that's an issue for another day. This is, you can talk about, oh, well, it's skewed more towards one species or another. I don't have all of these subspecies represented. I've got mimics. I've got this, that. The other thing, you can talk about all the differences. Licensing information comes back to there. You might note, this data set itself is under a public license, but the images themselves are under maybe a CC BY license. So please make sure that you adhere to that license when reusing these images. This is also, you can put a citation. If you've made enough modifications, please cite me, but also I made this data set out of some other source. Please also cite the original source of the data set and give that citation information. And then you also, of course, want to make sure that the grant contribution is in there, and that's already preloaded in the data set card, which is why it's important to know where to find it. It also has all this extra helpful information to guide you through. So that's what I've got on this. Does anyone have any questions on anything that I just presented here? Who here feels like the next time that they put together a data set of any kind, they know where to go to find a data set card and how to make sure that at the very least, we can trace back every step they did? All right. Woohoo! Okay, one last note that I'm going to make. If we come back to our workshop GitHub, handy dandy workshop GitHub, we have, Matt has updated the import issue, so woo, good job. All right, we have in Velma, we do have the completed notebook as well that we all walked through. We have our key learning objectives that we have talked about. Why do we care about provenance? So that we can find the source of the data. We know how it was created. Oops, sorry. We know how it was created and we could recreate if we need to, and we can attribute appropriately to the people that have done the work creating the data set. We know things we want to look for. We want to check for duplication. We want to check for our distribution and look through, and we want to document everything, record our assumptions, record all the changes we made, and say why you did them so that somebody else coming back can look at this and understand the steps you've taken and why you've taken them. It will also make it so much easier when you go to write the paper and you get to that data set section and you can basically just like copy out half the stuff from your data set card and then, form complete sentences out of it and you're done. No going back and reading notebooks and trying to figure out what you did. We also have this section with further reading, which has some more information about things like unique identifiers, which are something that are good to attach to our data. With the data set we worked with, the ID column served as a unique identifier. But if you're pulling things together from a bunch of different sources, you might need to assign that yourself. So here's some code to do that. Ways to avoid duplicates and data leakage. And there is another further reading notebook here, which goes into a bit more detail on the MD5 stuff and some of the intricacies and why things are different. It's interesting, so read it when you have a chance. And then just some general resources that everyone should know about that are really good. We've got the internal guidelines repo, which you all went to go get the data set card. And the internal guidelines repo is a constantly evolving repository. So there is more information added all the time. We have the Hugging Face templates, some more information about that as well, some guides, and the internal guidelines wiki, which is the most commonly evolving part, although much of this is now fixed to a certain point. I would like to highlight the repo guides for both GitHub and Hugging Face, as well as just a general metadata guide to help you think about things when you're doing data collection. I know there's a plan to do some data collection at the wilds. Maybe take a look over some of that before you go. Now you've got a project repo. What's the workflow? How do we want to work through things, both on GitHub and Hugging Face, because they each have some varying details. We've got a guide to using GitHub projects, which can be very helpful in organizing your entire project, especially if you're working with a bunch of people. You can assign tasks to everybody, see what's done, what's in progress, what's still to do. And then the things that change. One tab we've got here is this helpful tools for your workflow. I hinted at earlier when I talked about the paired pie file. GPText, if you work with notebooks, is really, really helpful with version control because you can have a paired file and it will show you your diffs more easily. Got some ideas on how it works. Rough for nice formatting of your pie files. This is an evolving page. If you have a tool that you find extremely useful, please share it with us. Something on setting up your virtual environments. Another one, glossary for Imageomics. Please, 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 everybody, as we talked about earlier when Tanya was talking about our, patience with each other and how we all have different specialties and language, add something to the glossary. This is here to help us all better communicate with each other so that we can say, if I'm talking about the CARE principles, you don't all look at me and go, what's that? I have never heard of that before. Well, it's here. Come look and come understand what it is that we're talking about. Learn more about these things so that we all have a good place to go for reference. So that also have a command line cheat sheet, little helpful tips with GitHub and some bash stuff. and then a link to the Google Drive because that's important. So we are still going to end early, but I am going to assign homework. Everybody go into the glossary and add one thing, one item to the glossary. And if you don't have access, then let me know and I will get you access. And then also check out the further reading. And remember, internal guidelines repo, the wiki has tons of information. So thank you all for your attention and I will release you to lunch.